Fleming gets a lot of credit for being the discoverer of antibiotics. However, that's not necessarily the full story. So penicillin was not the first commercially available antibiotic. Instead, the first commercial antibiotic was a drug called Prontosil. And this drug is it belongs to a class of drugs called sulfonamides, or sulfa drugs, if you've ever heard the term sulfa drugs. Sulfa drugs work by inhibiting within the bacterial cell the synthesis of folic acid. And we need folic acid too. So you're like, ooh, that's scary. If we need folic acid and bacteria need folic acid or folate, like if we inhibit that, isn't that bad? Well, for the bacteria, yes, because the bacteria have to make folic acid. They can't bring it into their own cells. We humans don't make our own folic acid. We eat it. We get it as a source of nutrition, and we can import it into our cells when we need it. So that's why, especially during pregnancy, they recommend that people take extra folic acid or extra folate because it's important for the development of the fetus, and you can take it as a pill. So you can ingest it. So bacteria can't, so that's why it would kill them. Now, this is not a compound produced by other microorganisms. It's not produced by a fungus. It's not produced by another bacterium. It's actually a chemical that was produced by Bayer, like the drug maker Bayer. The basis of the compound is that it's a dye. And you might remember when we talked about Paul Ehrlich, he figured out that dyes that were used to stain bacteria could kill them. So he, kind of published that, but then also other dyes worked too. So Bayer produced this dye, and it blocks the production of folic acid. It's effective against a lot of gram-positive bacteria like staph and strep. So the question then is, why do we not talk about this drug more than penicillin? There are a few reasons. So, when we talked about penicillin, we talked about Alexander Fleming. I did not tell you that he won the Nobel Prize for penicillin. Excellent. So, what about this drug? Why did we not hear about this? I will tell you that the scientist who characterized the fact that it killed bacteria, he also won the Nobel Prize in 1939, in fact. So prior to the mass production, prior to the isolation even of penicillin. So the chemists purified penicillin in 1940, but the scientist who characterized Prontosil won the Nobel Prize in 1939. Well, here's the issue. The scientist who worked for Bayer is a German company. So Bayer is now famous, of course, for things like, I think aspirin is probably their most famous drug. But, they make a lot of different things like Alka-Seltzer, Claritin, things like that. So they're a German company. It's the late 1930s. The guy won the Nobel Prize. However, Adolf Hitler did not allow Germans to accept Nobel Prizes because the Nobel Prize committee ticked him off by giving a peace prize to an anti-Nazi activist in 1935. So Hitler says, no, you can't have your Nobel Prize. And the scientist wrote a letter to Hitler, or to, whatever, the German government, and was like, can I please have my Nobel Prize? And they arrested him. The Gestapo arrested him because they'll do that. So he basically said, "Oh no, I'm really a Nazi. Look, here's my card. I'm a Nazi too." So yeah, they let him go, but he was a Nazi. They were all Nazis, and that's part of the reason that it wasn't as popular. So this drug only would have been available to Germany, Italy, and Japan, not to the rest of the Allied forces. It also doesn't work as well anymore. It's been replaced by better drugs. So that was the first commercially available antibiotic. So penicillin must be second. Actually, no, penicillin wasn't even second. The second commercially available antibiotic was called tyrithicin, and it was isolated from a soil bacterium in 1939. It also worked against a lot of gram-positive bacteria like staph and strep. It did not work against other bacteria like bacillus because it came from a type of bacillus bacterium. So it was used to treat wounded soldiers in World War II, which was great. Now, the problem with this drug, why did it not become more famous, is because it works by destroying the cell membrane. Remember, penicillin destroys the cell wall. We don't have a cell wall, so that's totally fine. But we do have a cell membrane. So it preferentially destroys the bacterial cell membrane, but sometimes accidentally also kills ours. So it was too toxic to use systemically, like you couldn't take it orally, you couldn't have it as an IV. The best you could do is probably use it topically if you had like an infected skin wound. So if we fast forward a lot, we now have tons of antibiotics. And this slide shows you the, 5 major ways that antibiotics can work. They can inhibit the cell wall, and so that's great because we don't have a cell wall. They can disrupt the cell membrane. That can be dicey because we also have a cell membrane. They can inhibit protein synthesis. We also make proteins, so why does this work? We make our proteins in slightly different ways from bacteria. So these drugs work against that slightly different way. We can inhibit the synthesis of DNA and RNA. So we also make DNA and RNA. So why does that work? Well, that works because, again, we make them a little bit differently. And so these drugs target the bacterial way, not our way. Or they can inhibit the synthesis of something like folic acid. We don't make folic acid, we're fine. So again, the idea is the best antibiotics work by targeting ways that bacteria and people are different. Okay, so that's something that's really important to remember. The best antibiotics work by targeting the ways that bacteria and people are different. So that's treatment of infection. In my opinion, something that would be even better is to not get an infection at all.